Hello friends, welcome to my YouTube channel EduVenture SG. So let's start doing another interesting word problem on whole numbers. Let's read the question first. Alex, Bala and Cindy shared a box of sweets equally. Then Alex, Bala and Cindy divided their shares into 2, 3 and 4 equal packets respectively. The total number of sweets in one packet of Alex, one packet of Bala, and one packet of Cindy is 52. What was the total number of sweets in the box at first? So what do we have here? What we have is that we have a box of sweet. So let's say this is my box of sweets. It is filled with many sweets. Okay. And then these three guys, Alex, Bala and Cindy, shared them equally. Means whatever is the number here, whatever is the number of sweets here, they shared it equally. Each of them took it equally. Okay. Then what they did, whatever share Alex had, right, he divided it into two equal parts, because saying that Bala divides it into two equal parts, then Bala has divided his share into three equal parts, Alex has divided it into two equal parts, and Cindy has divided her share of sweets into four equal parts, right? So let's start with drawing the model first. Okay, so let's draw this part first, where they all have equal number of sweets. So let's say okay, so let me draw it a bit longer. Okay, so okay, so let's divide it into three equal parts. So let's say this is, the first one is Alex share, the second one is Bala's share, and the third one is Cindy's share. So you can see here that all of them are equal. Lengthwise, they all are equal, same. But then Alex divided his sweets into two equal packets, into two packets. That means he put the sweets into two packets, right? Each of them have same number of sweets. So let's show it. So let's divide his share into two parts. However, Bala divided his share into three equal packets. So let's show it here. So he has divided his share into three equal packets. However, Cindy decided to divide it into four equal packets. So let's show it here. 1, 2, 3 and 4, right? So you can see here Alex has divided his share into two packets, Bala has divided his share into three packets, and Cindy has divided her share into four packets. That's another thing. Each of them have same number of sweets. That means, that also shows us, right? See, in each packet of Alex, right, there are maximum number of sweets. I mean, the Alex packets have a lot more sweets compared to Bala and Cindy. And Bala's one packet have a lot more sweets than Cindy, right? How much more we don't know, but we can see from here, right? Each packet, the packets of each one of them have different number of sweets. Okay, so in order to solve this, our first aim would be to find out, like, what could be the minimum number of sweets each of them have, right? Or what could be the minimum number of sweets like Alex, Bala and Cindy might have, right? Because that number should be divisible by all the three numbers, right? 2, 3 and 4. That number should be divisible by 2, 3 and 4. That's why it's a requirement, because each of them are able to divide it equally. That number should be divisible by 2, 3 and 4. So what could be that number? That number has to be the least common multiple of 2, 3 and 4, right? That number has to be the least common multiple of 2, 3 and 4. So we have studied multiples of a number in primary 4. So let's do it. Let's write them quickly. So let's write multiple of 2. That will be how much? 2, 4, 6, 8, 10, 12, 14 and so on, right? Similarly, let's write the multiple of 3. That will be 3, 6, 9, 12, 15 and so on. And the last one is, let's write the multiple of 4. So that will be 4, 8, 12, 16, 20 and so on, right? Now what do you think? If you look at it closely, what is the least common multiple? Clearly it's 12. See, 12 here, 12 is here and 12 is here. So the least common multiple of 2, 3 and 4 is 12. That means the minimum number of sweets that Alex, Bala and Cindy could have is 12. It cannot be less than that. Otherwise that number, it won't be divisible by all the three numbers. All the three numbers means 2, 3 and 4. Okay, so I'm not saying here each one of them are having 12 sweets, but I'm saying minimum they will have 12 sweets. That means it could be a multiple of 12, right? So from here we can say that tells us, so let's write it. So the least common multiple of 2, 3 and 4 is what? Is 12, right? That means, that shows that each of them have 12 units of sweet, right? 12 unit of sweets. That means since the minimum should be 12, it could be multiple of 12s, right? So let's we don't know what multiple of 12, so let's assume that each of them is having 12 units of sweets. Okay, given that each of them have 12 units of sweets, what do you think, how many units of sweets are there in one packet of Alex? Why I'm interested in finding how many sweets are there in one packet of Alex is because here in the question we have the total number of sweets in one packet of Alex, one packet of Bala and one packet of Cindy is 52. So we have to find out like how many units of sweets are there in one packet of Alex, Bala and Cindy. So let's do that. So the number of units of sweets, so number of units of sweets in one packet of Alex would be how much? Would be 12 unit divided by 2. Why divided by 2? Because he divided all his sweets into 2 packets. So one packet will be having 6 units, right? So one packet will be having 6 units. So 6 here, 6 unit will give you 12 units, right? Similarly, number of units of sweets in one packet of Bala, any guesses? Would be how much? See, Bala is also having 12 unit and he has divided his sweets into 3 equal packets. That means 12 divided by 3 will be 4 units. Means his 3 packets each will be having 4 units each. Okay, each of them will be having 4 units. Now exactly the same thing, we have to find the number of units of sweets in one packet of Cindy. It's very easy. I think everybody knows it. like it will be 12 unit divided by 4, 3 unit, right? So each packet of Cindy would be having 3 unit, 3 unit, 3 units and 3 unit, right? Each of them will be having 3 units of sweet. Okay, now what do we have here? We know that one packet of LX, one packet of Bala and one packet of Cindy, total is 52 sweets. Okay, so from here we can say that, okay, 6 unit, which is 1 unit of LX, plus 4 unit, which is one packet of Bala, and another 3 unit, which is 1 packet of Cindy, is equal to how much? 52, right? 52. That means 13 units is equal to what? 52, right? 13 units of sweets is equal to 52. So from here we can say 1 unit of sweets would be 52 divided by 13, which will give you 4. Okay, 4. Then let's look at the question. What was the total number of sweets in the box at first? So the total number of sweets in the box was what? Total of what all LX, Bala and Cindy have all together, right? So all together they have 12 unit plus 12 unit plus 12 unit. They have 36 units, right? So the total number of units of sweets is 36. So that you can say that total sweets would be 36 units, which is equal to 36 times 4. That will give you 144 sweets, right? So to answer our question, the total number of sweets, okay, what was the total number of sweets in the box at first? So let's write our answer. Okay, the total number of sweets is 144. Okay, it's 144. Okay, so that's our answer. Hope you understood the solution of the problem. It's a very interesting problem, and you will see a lot of number of times in your test papers. So make sure you understand it, and please don't forget to subscribe the channel. See you in the next video. Bye.